Now let's look at the code that you've added in the last coding exercise. And there's a lot happening in just these 3 lines of code. So at a high level, we're creating an ArrayAdapter that contains a list of strings as its data source. Then we're searching through the view hierarchy for the ListView, which was defined in our XML layout. And then we're associating the ArrayAdapter with the ListView. For a more detailed explanation of what's happening, let's take a look at it one line at a time. First, we create an ArrayAdapter object using the new keyword and the constructor with 3 inputs. We're storing it in a new variable that we're calling ItemsAdapter, where the ArrayAdapter is its data type. Now, how did we know to pass in these 3 inputs? Well, let's take a look at the documentation. So here's the Android developer documentation for the ArrayAdapter. And if you search online for ArrayAdapter Android, you can also find this page. Now let's scroll down to the section called Public Constructors. And this tells us the different ways we can create a new ArrayAdapter. Each constructor requires different inputs. So we've been using the second to last constructor here. And here's the code that we've been using in the numbers activity file. So notice that we pass in the context, which refers to the numbers activity, the layout file, and a list of objects. Now the reason we need a context is because we're creating views. Since the numbers activity is a context, we specified the word this to refer to the numbers activity. The second parameter is the list item layout file. So normally we refer to the layout files in the form of r.layout for layouts we've defined, followed by the name of the layout file. So in this case, we specify android.r.layout because the Android framework actually predefined an XML layout file called simple list item 1, and we can just use that one that Android predefined for us. So the last parameter is the list of objects, which will be the data source for the ArrayAdapters. In our case, it's words. Now earlier in this lesson, we discussed generics when we created a string array list. Remember, focus, this is array list and not ArrayAdapter. Remember, because ArrayList is a generic class, we can rewrite it to be ArrayList and have E inside the angle brackets to indicate that it's a generic class. Now remember that E is a type parameter or placeholder which can be swapped for a specific object type, such as string when we create an instance of an array list. Now creating one generic class allows us to decide the types of data it will store later on, rather than having to create many specific classes, such as a string list class, an integer class, a Boolean class, or any other object type list class. So going back to our discussion about array adapters, here's the documentation for array adapters. Now we see here that ArrayAdapter has the angle bracket T syntax, which indicates that it's also a generic class. Now T, like E, is a type parameter that can be swapped out for a specific data object type. And specifically, T stands for data type because we need to say what types of data are in the array. And in our case specifically, we have an array of data type strings. Now we're creating an ArrayAdapter that specifically takes in strings. And we'll be creating list item views for each of these string elements. So back to this comparison table, which demonstrates why it's better to create one generic class versus creating a class for every type of list possible. Here, we see that for ArrayAdapter, we can replace the T with any other object data type. In our case, we're going to replace the T with the string data type. All right, wow, there was a lot happening in that one line of code. So let's move on to the second line. So here we're looking in the view hierarchy for a view with the ID name list, and the findViewById method returns a view, and then we cast it into a ListView data type. The casting won't work if we found a text view or an image view. In this case, the casting works because we actually did find a list view in the layout. So we store this list view into a variable called ListView, and we can call methods on it and interact with it while the app is running. Now on to the last line of code. And here it says ListView.setAdapter, and it takes in ItemsAdapter as its parameter. So we're calling the setAdapter method on the ListView object we just defined in the previous line. Now if we go to the ListView documentation and search setAdapter, we see that this method takes one input parameter. It requires an object of type ListAdapter. But in our code we only have an ArrayAdapter, not a ListAdapter. So let's click on ListAdapter to find out more information. Alright, so now we're in the ListAdapter documentation. And if we scroll down a bit to the public methods, we see that it has two abstract methods. If we look at the top of the doc, it says that ListAdapter is an interface. And remember we learned about interfaces in the last lesson and how onClickListener is an interface. But we need to provide an implementation for the methods. Well, that means that we need to create a class that implements the ListAdapter interface so that we can properly set an adapter on the ListView. Well, luckily, the Android team has already done this for us. And we're free to create our own class that implements the ListAdapter interface, but ArrayAdapter fits our needs. So let's take a look back at the ArrayAdapter documentation page. And we can look at the class hierarchy diagram. So ArrayAdapter extends from BaseAdapter. So let's check that out. So it says here that BaseAdapter is an abstract class. And look, it implements the ListAdapter interface. So this means that BaseAdapter can be used whenever ListAdapter is required. And ArrayAdapter can be used wherever ListAdapter is required. Alright, so I know there was a lot of links to follow through and it might have been a maze. So thanks for trying to keep up, and I'm going to help summarize all the information that we just talked about. Now in this graphic that shows the differences between the concrete class, abstract class, and interfaces, we're going to discuss how adapters apply into each of these three categories. So the ListView setAdapter method requires a ListAdapter as its input. So the ListAdapter is an interface, and this means that no states are implemented and all methods are abstract. It also turns out that the Android team has created a BaseAdapter class, which is an abstract class that provides an implementation of some of the ListAdapter methods, but it also leaves some other methods as abstract. Now this is where the ArrayAdapter comes in. The ArrayAdapter is a concrete class that has methods implemented. So no methods are left abstract, and we can create an object instance of the ArrayAdapter and use it in our app. So since we verified that ArrayAdapter is a ListAdapter, we can pass in the itemsAdapter variable as the input to the ListView.setAdapter method call. Hey, awesome work. And now you know how powerful these three little lines of code are. I know it was a lot of information to take in at once, but it's definitely worth it to take the time to understand all of it, because the adapter is a really common pattern in Android. So the adapter knows about the data source, whether it's an array or a list, and it knows how to present each of these items as a view. Meanwhile, the list view handles showing these views on screen, detecting the user's touch gestures, and maintaining state on where the user is within the entire list. And here are the three lines of code that summarize this interaction between the list view and the ArrayAdapter. We'll dive more into that later on. For now, you can think of it as a separation between the user interface and the data model. It's not exactly a clean separation because the ArrayAdapter deals with the views, but primarily the list view is in charge of the details of the user interface, while the adapter is in charge of the data. Now, because it's separated, you can swap out one part for another. For example, you can hook up the same ArrayAdapter to a grid view. The ArrayAdapter stays exactly the same, and instead of showing list item rows, the grid view now asks for grid item views. So this becomes position 0, position 1, and so on and so on. And the adapter provides each of these views still. So have you seen the drop-down menu in Android? Well, in Android speak, these are called spinners. And guess what? To populate each item in the drop-down, we attach an adapter to it. So each item in the menu comes from an item in the data source. So as you can tell, you'll run into the adapter pattern as you build Android apps. So it's critical that you understand it now. In the near term, we're going to see the pattern come back again in Lesson 5. For this next task, try to modify some of the list view adapter code and see what happens. Then try to use the grid view instead of the list view. So grid view also recycles views and needs an adapter to know what information to display. So this is all for experimentation purposes. And at the end of the task, I'll ask you to go back and revert your code to using list views. So here are the specifics of the practice. Instead of using a list view, try using a grid view to display the words in the numbers activity. You can use the same adapter that we created earlier. And if you do need some help, you can refer to the article that I've linked below that discusses grid view. But I want to let you know, before you go too far down the rabbit hole and start copying and pasting a lot of code from that article, you should be aware that this task of changing from the list view to a grid view can be done in the Miwok app by simply changing a couple of line of codes. So after you've tried out this task, go back and change your code to using a list view again. All right, best of luck and have fun experimenting.